Good evening. So I've been asked by KGHM to do a presentation on noise and vibration assessment. So I'm going to start my presentation talking about why noise and vibration assessment is required in a study. So in both cases, noise and vibration are valuable component in the application information requirements, their potentials for environmental effects, and they both required in the environmental approval process. And in both cases, we need to quantify the prediction results and compare to the regulatory compliance limits. So I'm going to start talking about the noise assessment process here. So these are the topics I will discuss in a little more details. We got to consider how many scenarios we will look at in a noise model, who are considered as noise-sensitive receptors, the type of noise sources we considered, and what do we use as acoustic modeling tool. Most importantly, there are regulatory frameworks we used, and if we required, mitigations. So for noise modeling scenarios, we will consider 3 different scenarios here. The first one is construction phase. It consists of some of the following components: excavation, grading, road and bridge work, infrastructures. And for the operational year, we'll look at year number 1 and number 14. We select year number 1. It has less production volume, however, it has a less barrier effect from the terrain because the pit won't be as deep as year number 14. And at year number 14, it has the highest production rate. So this map here shows all the human health receptors we considered in assessment. So for noise assessment, the focus will be on the rural residences as well as the city of Kamloops. So for the city of Kamloops, we will be looking at residences, school, and hospital. And bear in mind that the project boundary and the mine design, if there's any change there, they will have impact on the noise result as well. So in our noise assessment, during the construction phase, we will look at different noise emission equipment, like dozers, excavators, graders, haul trucks, and blasting. In the operation phase, we'll look at sources from the open pit, from the process facilities, tailing facilities, blasting again, waste rock management facilities, the ore and waste transportation, concentrate shipping area, and the explosive material transportation. So acoustic modeling is the mathematical simulation of how noise propagate in the atmosphere. So the modeling, which does all the hard math, is based on an international standard, ISO 9613, and this is the standard recognized by regulator in Canada as well as internationally. As I mentioned earlier, we will construction year number 1 and year number 14. So in the acoustic model, we will consider some of these factors here. Octoband, which represent the frequency content of the noise sources. Barrier effect from terrain effect from the surrounding area. Air and ground absorption. So similar to vibration, when a noise source is propagated out at a distance, the acoustic energy will be absorbed by the ground as well as by air. Directivity, noise sources will have directivity. Let's say one side of the building might be noisier than the other side. Reflection from structures, and meteorology as well, such as wind, relative humidity, and temperature. So the regulatory framework in BC is based on the Oil and Gas Commission noise guideline. So the guideline established noise limit for a receptor. They call this limit the permissible sound level. So for each receptor, depending on your population density and the proximity to a road or railway, they define different sound limit. So in the most stringent case, let's say you're in a population density of 1 to 8, they call dwelling per section, and you're far enough away from any road or railway, the noise limit is 40 dBA, or decibel level. So to put it in perspective of comparison, this graph shows some of the common sound we experience in daily lives. So for airplane, you're talking about 140 dBA, and I call it dBA decibel level, A-weighted. The reason I call it A-weighted is because our human perception to noise have different sensitivity to different frequency. So they put this A-weighted factor in it to compare our human ear response. So in comparison, 40 dBA as the limit is similar to an indoor level in a library, which is about 38 dBA. So in the federal regulatory framework, we will use the Health Canada Noise Guideline. The Health Canada Noise Guideline considered health effects from the noise emission. So some of these health effects they consider are sleep disturbance, annoyances, and speech interference. In addition, they consider construction noise and low-frequency noise as well. So we do our noise prediction assessment, and if the prediction level exceeds any of the noise criteria I mentioned early on, so mitigations might be required. So here are some examples of mitigations. We could reduce the noise sources by, in some cases, putting equipment in the building, such as big crushers, big mills, and we could install mufflers at the exhaust, and in some cases, putting in barriers. And barriers could be engineered barriers, or we could use the terrain itself as barrier. And typically, when you increase the distance from noise source to receptor, it would mitigate the source. In addition, a noise management plan could be in place, and this noise management plan may consist of the following: temporary or permanent monitoring stations, scheduling of events. As Frank mentioned early on, if the meteorological condition doesn't favor blasting, you could reschedule it, and a complaint mechanism. So the company is aware of any noise issue. So when we get a chance to do our noise assessment, we have results. We will predict the noise level at each of the individual receptors. In addition, we will show our result in the format of a noise contour for the whole study area. So this is an example of the noise contour. The noise contour is very similar to a topography map. Instead of showing elevation lines, it just shows equivalent sound level for different areas. And our results will be provided to other disciplines as well for further assessment. So Frank discussed great length about vibration assessment, so I will cover the vibration assessment here again. We will look at blastings. We will look at ground vibration from machinery and haul truck traffic as well. So the assessment methods are based on some of the following sources. Ontario Ministry of Environment has a guideline on blastings. Technical textbooks, handbook, or journals. As mentioned before, there is test blast result for comparison purpose. And it was covered in the previous presentation. There is not any regulatory framework for vibration impact or effect in BC. So in Canada, the Ministry of environment from Ontario, they have specific limits, as well as the US Bureau of Mining. So when you look at these standards or the criteria from the MOE or the US Bureau, the limit they come up with are fairly compatible. They're talking about 120 dBl for the air blast overpressure, for air vibration, and for the ground vibration, you're talking about 10 to 19 millimeter per second. And for machinery and haul truck, City of Toronto has a construction limit of, you can't really see here, it's 25 millimeter per second. And again, these limits are frequency dependent, and the higher the frequency, typically your threshold is higher. So this concludes my presentation, and we have time for questions from the audience.
Well, thanks for keeping that presentation to the allotted time. So we'll start with the first question at the center mic.
Thank you very much. I wonder, can you tell us how these noise vibrations and sound compare with existing noises in our community today? And I'm thinking of things like jake brakes on trucks, the railroads, airplanes, buses, stuff that we live with every day. Is this any worse than that?
That's a very interesting question, a good question too, because early on I showed that noise limit of 40 dBA, and if I could go back to the graph here, so these are some of the typical levels you experience in your daily life. Again, there's two factors. One is the absolute sound level you measured, and the other factor is your perceptibility to that sound level. So it's difficult to quantify sound level for the whole city of Kamloops. If everybody quiet here, and you just listen to the ventilation, you're probably at about 35 dBA. But as you walk outside, all the way back to the car, you're going to experience all different kind of sound levels. So depending on where you are in the city, and the ambient noise as well. So it could be a windy day, and then you have a lot of trees and leaves in the area. So you could have a higher elevated ambient level. And if you're in downtown when there are a lot of traffic, and there are a lot of conversation, you could be at 45 or 50. But typically, in most environments, you will have a higher daytime ambient sound level than in the evening. And that's why when you look at some of these regulatory limits, the one I show here, these are the nighttime limits. So for daytime limit, they are typically 10 dBA higher. So in this case, 40 dBA for that resident category would be for nighttime. For daytime, would be 50 dBA.
Okay, how would, let's say, the noises from the railroad compare? With what
Depending how close you are to the railway. Depending how close you are to the track. So if you are depending on the kind of train, the kind of cart, the load, if they got to pull the horn, you could be at 60, 70, or if you are at different further distance away, this goes varies.
Okay, thank you very much.
You're welcome.
Thank you.
Thank you very much. Just a comment. Going between DBA and DBL within your talk and between talks is confusing, I think, for people. And I think you need to make it clear that they're not the same thing.
I think this question deserves a written response in the more technical details. It is a very confusing topic and subject too, because we can measure many things in decibel. Decibel is basically a logarithmic scaling. So you can measure earthquake or even distance in decibel. So what decibel do is you have a reference level. You compare a measurement unit with this reference level and apply the logarithmic function to it. And the reason they do this is because when it comes to sound pressure level, you're dealing with some astronomical big number. So in logarithmic scale, it's a lot easier to quantify it. So you are talking about air blast overpressure as dBl, The L stands for linear, so there's no filter, no weighting, nothing applied to that. It's actually very different from community type of noise, which I show here, measuring dBA. Because when they applied this A-weighted filter, which I mentioned earlier, is similar to our ear response to common sound. For example, at 31.5 hertz frequency, they actually minus 50 dB just to represent how our ear don't perceive low frequency noise that well. And for general human being, general public, our noise audible perceptibility is from 20 hertz to 20,000 hertz. And as Frank mentioned, a lot of these air blasts energy, they actually below the audible range. So you might not even be able to hear it.
That was a comment, and thank you for that. My question is whether in the calculations you're going to do or have done, you take into account the specific meteorological conditions that are unique to where the mine is and where the urban areas are in our city. And in particular, we have quite pronounced katabatic winds that are present a good part of the year. And they'll produce a drainage wind out of the plateau for about half the day, let's say, typically in the cold part of the day. And you'll get winds of 5 to 10 kilometers an hour coming down the mountainside. And then it'll switch on a day like this.
So does it usually happen at the earlier part of the day when the wind switch?
It'll typically happen between about 8 o'clock in the morning, after the sun is up, and a little later in the day, depending on the time of the year. And then you'll have strong north winds, and they'll come out of the valley, and they'll go up the slope. So both of those winds will affect the transmission of sound.
Yeah.
And is that going to be present in your calculations?
The ISO 9613 international standard I mentioned, it does consider a mild downwind condition, which is 3 meters per second at 10 meter elevation. So that is actually a more conservative, that condition is favorable for sound propagation. So there's some conservatism built in there. However, if you're talking about a higher wind level, so it will enhance the propagation. And it is difficult to quantify your weather pattern in 2 or 3 models for the rest of the year.
But you'll need to take that into account if you're looking at the impact on homes in a particular area that are experiencing those winds, which are going to impact what level the sound is at when it gets to the home.
Yeah. So indeed, I mean, I have to say we will consider some of this inversion condition and upset condition. However, if you look at the regulatory guideline and limits, they are based on ISO standard. So this 40 dBA is set at a limit so that there's minimum community annoyance. So it does not guarantee that, well, okay, one day of the whole year is not going to be audible.
Yeah, but it might be 40 dBA when there's no wind, and it might be 60 dBA when there is wind.
Yeah.
That's my point, is unless you have measurements that characterize the local meteorology, you can't really address that in terms of the impact on people.
And then there's another interesting factor there too, is when you are at a higher wind speed, your ambient level increases as well.
Mm-hmm.
So the ambient level actually might have even a masking effect.
Well, that's for you to determine in
Yes.
your model.
So as I mentioned earlier on, we will consider some of this inversion condition, and then we'll talk about the audibility of that. And again, that really depending on your noise sources and the distance away from the noise sources and the perceptibility of the receptor. So as Frank mentioned earlier on, there is a lot of distance buffer between the project and the city, as well as the terrain actually will provide some natural barrier to your project as well.
Great questions. Next.
Thank you. You stated that there is no regulations in British Columbia.
For the vibration effect only.
So there is an enforceable regulation for the noise.
Yeah, actually, this is what I show here. It's based on the BC Oil and Gas
Yeah.
Commission noise guideline.
And who would be enforcing that? In other words, who actually is going to enforce that regulation?
I think that's just a question for the regulators.
Okay, so you don't know who those people are.
I know the regulation, but I do not know who specifically in the regulatory framework going to enforce it.
Is it Ministry of Environment, do you think, or do you know?
I have to do some research to find that,
Yeah.
find the answer for you.
Right, thanks.
Yeah.
And final question, and we'll move to the next presenter.
This is really a follow-up question. It's been fascinating listening to the scientists and engineers talking, but just to bring it down to a layperson's level, if you're sleeping in Aberdeen or Pineview and there's a wind coming from the mine and it's the middle of the night, is your sleep going to be disturbed? I can't read those diagrams, so they're too small. So will your sleep be disturbed?
Again, I kind of mentioned early on, there are many factors that are involved. There's how loud is the noise source, how high the wind is going to be, and the ambient level associated with wind, and the perceptibility of noise. Because I personally sleep through everything, but my wife, the slightest sound, she'll wake up. So it's difficult to quantify that without knowing the exact noise sources from the mine at this point. So again, that depends on many factors. But I did mention early on this 40 dBA from the BC noise guideline. This level is designed to minimize any community annoyance.
Great, thank you. So if we didn't get to your question, there will be an open forum at the end of the session tonight that those of you who missed the specific piece here can have your question again answered by any of our panelists. So thank you, Jonathan, and we will move to our next presentation, and after this presentation, Q&A, then we'll have a short break. I think it's Hamish, if I'm
Okay, thank you.
correct.